students, we will see how halogens are added in alkynes. Usually this addition takes place in 2 steps. Right students? So we will understand this reaction with the help of an example. We will write the ethyne molecule H, C, triple bond, C, H. In the first step, first molecule of chlorine is added. This is in the first step. Now students, so first molecule of chlorine is added and as a result we get 1,2-dichloroethene molecule. So in the first step here the product which is formed is 1,2-dichloroethene. 1, 2. So the name of the product will be 1,2-dichloroethene. 2-dichloroethene molecule. Students, still there is a double bond between 2 carbon atoms, right students? So it can add one more molecule of chlorine. Now we will see what is the next step of the reaction. The second step of reaction. In the second step, we have CH, double bond, CH, Cl, Cl, 1,2-dichloroethene. Now students, in the second step, one more molecule of chlorine is added. One more molecule is added, right students? And we will see what product is formed after the addition of one more molecule of chlorine. Here we will get a saturated molecule which has 4 chlorine atoms, that is tetrachloroethane molecule. This molecule has 4 chlorine atoms, that's why this is known as tetrachloroethane. Right students, I hope this reaction is clear to you students. Now students, we will see the next method which is used. We will study the next reaction of alkynes, that is reaction with KMnO4, that is potassium permanganate. Students, alkynes do not react with dilute alkaline solution of potassium permanganate. They are oxidized by strong alkaline potassium permanganate. And the product which is formed is known as oxalic acid. In the first step, 4 hydroxyl groups added across the triple bond in the molecule. Now students, we will understand this reaction with the help of example. For example, we have ethyne molecule. Right students, and we react ethyne molecule with concentrated potassium permanganate, 2KMnO4, in the presence of water. In the first step, right students, this is the first step of the reaction. Now we will see what product is formed after this reaction. After this reaction, we will get 2 hydroxyl group across the site of triple bond. We get 4 hydroxyl group students here, as well as with the first carbon, with this carbon as well as with this carbon. It is 1,1,2,2 tetrahydroxyethane. What is the name of this molecule students? This is tetrahydroxyethane. Why it is known as tetrahydroxy? Because it has 4 hydroxyl group. That's why this is tetrahydroxyethane. This molecule is formed students. Beside this molecule, the other products which are formed is manganese dioxide. We get manganese dioxide, right students, plus potassium hydroxide. This is the first step of the reaction. Now students, we will see what will happen in the next step of the reaction. In the next step, again we write tetrahydroxyethane molecule. We have tetrahydroxyethane. Here we have OH, OH, similarly OH as well as OH. In the next step, in this molecule, that is from tetrahydroxyethane, two water molecules are eliminated and we get another product that is known as glyoxyl. We will see how two water molecules are eliminated. Right, students? Hydroxyl group from this carbon, right, students, and hydrogen from this carbon will remove in the form of water. Similarly, hydroxyl group from this carbon and hydrogen atom from this carbon, they will remove in the form of water. Hydroxyl and hydrogen, hydroxyl as well as hydrogen, they will eliminate it in the form of water, and as a result here we get the molecule like this. We get this molecule, students. We have double bond between oxygen as well as carbon. This molecule is known as glyoxyl. Glyoxyl. Now students, this molecule is oxidized. Glyoxyl molecule which is formed, this molecule is oxidized into oxalic acid. Now we will see the oxidation of glyoxyl molecule. How glyoxyl oxidized into oxalic acid. We have glyoxyl, C double bond O, H, right students, in the presence of atomic oxygen. This molecule oxidized and we get oxalic acid, that is HO, C double bond O, C double bond O, OH. This molecule is known as oxalic acid. We know very well what is the molecular formula for oxalic acid. C2H2O4. This is the molecular formula for oxalic acid, right students? And here we have the structural formula for oxalic acid. I hope reactions of alkynes are clear to you, students.